So now let's graph this equation again. Now this equation is different because it's not in slope-intercept form. So there's a couple ways you can do it. You can either convert this to slope-intercept form, or you can just plug in and find a couple points that would work on this. So I'm going to show you both ways. In fact, the first way I'm going to show you is going to be to convert it to slope-intercept form. Remember, that means y equals mx plus b. So how do I put that into y equals mx plus b? Well, I've got to get the y by itself. So I'm going to first, here, I'll rewrite the problem over here. So I have to make it look like that. So I can subtract 5x from both sides. Now the y is still going to be negative if you do that. I'm going to write the 5x first. I could have written negative 3 minus 5x, but I'm just moving them around so it looks more like this. Putting the x first, right? Mm-hmm. And now there's a negative here. How do I get rid of the negative? Do you know what I do to get rid of the negative? Mm-hmm. I multiply everything by negative 1. Multiply this entire equation by negative 1. That'll change all the signs. So I've got y equals 5x plus 3. Okay? So this equation and this equation are the exact same. They're just written in a different form. Kind of like 1/2 is the same as 2/4. They're just written in different forms. Follow? Mm-hmm. So now I'm going to graph this by using the slope-intercept method. Here's my y-intercept right here. My y-intercept is 3, so go 3. There's your y-intercept. 0, 3 is that point. And the slope is 5. M equals 5 over what? If there's nothing on the bottom, what's on the bottom? Right. So the slope is 5, which means I'm going to go up 5 and to the right 1. Now notice if I try that here, I'm going to be off my graph. So instead of going up 5 and to the right 1, I'm going to go down 5, starting here. I'm going to go down 5, 1, 2, 3, 4, 5, and instead of going to the right one, I'm going to the left one. Because negative 5 over negative 1 is also 5. So I went down 5 and to the left one. So there's my other point. Now I can take my line, connect those 2 points together, like that, and there's my line. Now the other way I could have done it is with this right here. I could have just plugged in a couple points. I could have plugged 0 in for x. If I plug in 0 for x, let's do the work underneath here. I would get 5 times 0 minus y equals negative 3. And then, so that means this is 0, right? Mm. That means negative y equals negative 3, which means y equals 3. So if x is 0, y is 3. There's 1 point. Oh yeah, look at that. There's 1 point. And now we need 1 more point, because remember, 2 points determine a line. All you need is 2 points to get a line. So let's plug in another. Now let's, instead of plugging in 0 for x, let's see what happens when we plug in 0 for y. So I'm going to plug in 0 for y. I'm rewriting the equation, but I'm going to plug in 0 for y. Now let's solve that for x. X equals negative 3/5. So negative 3/5, comma 0. I guess where that is. It's that point right there. Negative 3/5, comma 0. 0, comma negative 3. Those 2 points. Now I just draw a line between them. Either way works. You could either convert it to points to slope-intercept form, or leave it in what's called general form and find a couple points. And you didn't have to find the intercepts, but those to me are the easiest ones to find, because 0 is an easy number to work with.